Assalamualaikum and good day everyone. Today I will be presenting the project scope, data source and preliminary data analysis for our study. Our study focuses on Kuala Terengganu, located at latitude 5.3290 and longitude 103.1370. This area was selected due to its significant rainfall variation throughout the year. The data we obtained from NASA Power, covering daily climate, records from 2020 to 2025. The two main variables used in this study are rainfall and temperature. For data preparation, we use R programming to clean and process the dataset. Additional features such as year, month, season, and also rainfall risk classification were created. The dataset was also checked for quality and contained 0 missing values. Rainfall was classified into 3 categories, which is light risk, which is 1 to 10 mm, moderate risk, which is 11 to 30 mm, and heavy risk, which is 31 to 60 mm. From the exploratory data analysis, we observe the fluctuations in rainfall over time, a concentration of lower rainfall values in the histogram, and a positive relationship between temperature and rainfall in the scatter plot. That's all for my section. Thank you.
Next, I will present about the descriptive statistical analysis. So from our data set, from the table we know that the temperature is 27.7 from the means. That we know that with the lower medians, it suggests that distribution influenced by higher value. So the standard deviation indicate the higher variability, and we know that for the average temperature of 27.7, we know that they indicate the study areas experience consistently warm and tropical weather bias. The peak analysis and the extreme, we know that the highest total rainfall is 295.82 mm with the multiple extreme rainfall. So we know that we're using the box plot and the histogram graph to analyze and confirm the presence of extreme rainfall days, typically daily volume. So from the graph mid-year temperature peak, we know that the daily temperature reached their highest point, that means approximately 31 degrees Celsius between day 100 to day 200, and the temperature range stability is around 25 degrees Celsius to 31 degrees Celsius. Then year-end rainfall surge, from the graph we know that the precipitation peaked sharply after day 300. So for the rainfall distribution analysis, dominance of low rainfall days, we know that the highest amount value of the rainfall amount in the range 0 to 10 mm. That means the frequency trend is extremely high frequency. It's more than 1000 day equivalents. Last but not least, what is the interpretation and the climate risk? First, it can increase the flood risk between the local and the state and the overseas. Then second, infrastructure challenge may be one of the challenge in our country. And the last but not least, humidity rainfall correlation. Thank you.
Moving on to the slide 3, let's look at our annual weather matrix, which is where analyze the 365-day daily environmental trends for Kuala Terengganu. By plotting this data, we can clearly identify a distinct mid-year temperature peak and a major year-end with season surge. Looking closely at our temperature data, the area experiences consistently warm tropical weather with a mean temperature of 27.7 degrees Celsius. What's highly interesting for regional planning is the stability of this climate. Our daily temperatures consistently fluctuate within a narrow 6-degree band, staying between 25 degrees and 31 degrees Celsius year-round, with the highest point peaking around day 100 to day 200. However, when we look at the year-end rainfall surge graph, we see the massive variability. While the historical daily mean sits at 9.57 mm per day, this number is heavily skewed by extreme events. In fact, precipitation peaks shortly after day 300, reaching extreme threshold near 300 mm around day 315. Our box plot and histogram analysis confirmed that 2022 recorded the absolute highest daily volume at 200 95.82 mm, representing significant outlier events. As civil engineers, understanding these trends is critical for two major reasons. The first is the frequency of these heavy year-end rainfall peaks translate directly into an increased flood risk for the local community. And the second is it creates the massive infrastructure challenges. This significant variability means conventional drainage design based strictly on daily average will fail during the monsoon surge. We must utilize these data distributions to evaluate the capacity and the efficiency requirements of the regional stormwater infrastructure to withstand this climate risk. Next, my teammate will dive deeper into how we statically broke down this rainfall distribution.
Assalamualaikum and good day everyone. For this section, I will explain about the regression analysis predicting rainfall from temperature in Kuala Terengganu. The objective of this analysis is to determine whether temperature can predict daily rainfall. In this model, temperature is the independent variable while rainfall is the dependent variable. Using simple linear regression, we obtain the following equation. Rainfall equals to 91.79 minus 2.96 multiplied by temperature. This equation shows a negative relationship between temperature and rainfall. Specifically, for every 1 degree Celsius increase in temperature, the predicted rainfall decreased by approximately 2.96 millimeters. This suggests that higher temperature are generally associated with lower rainfall amount in Kuala Terengganu. As an example, when the temperature is 32 degrees Celsius, the model predicts a rainfall value of negative 3.02 millimeters. Since rainfall cannot be negative in reality, this is interpreted as 0 millimeters, meaning very dry condition. Next, let's look at the model performance. The R-squared value is 0.02886, which means temperature explains only about 2.9% of variation in rainfall. Therefore, temperature alone is a weak predictor of rainfall, and many other factors such as humidity, wind patterns, and monsoon condition also can influence rainfall. However, the p-value is 1.18 times 10 to the power of negative 15, which is smaller than 0.05. This indicates that the relationship between temperature and rainfall is statistically significant. So we reject the null hypothesis and conclude that temperature does have a measurable effect on rainfall. In conclusion, although temperature has a statistically significant relationship with rainfall, it is not strong enough to accurately predict rainfall on its own. Nevertheless, the findings can still support rainfall monitoring, drought assessment, and long-term regional planning. Thank you.
So on this slide, I will explain the machine learning, modeling, and performance used in our climate risk assessment study. First, we applied the K-mean clustering to identify rainfall risk categories. Using the elbow method, we found that K equal to 3 is the optimal number of clusters, representing low risk, moderate risk, and high risk rainfall conditions. The scatter plot shows how these rainfall risk categories are distributed based on temperature and rainfall intensity. We can observe the higher rainfall values are generally associated with the high risk clusters. Next, we use the K nearest neighbor KNN algorithm to classify climate risk levels. The graph shows the model performance for different values of K. The highest accuracy was achieved at K equal 21 with an classification accuracy of 76.52%. These results demonstrate that machine learning can effectively identify climate risk patterns from weather data. That is all from us. Thank you.